Hello, this is Jennifer. So today we're going to talk about LeetCode 206, reverse linked list. This question asks you to reverse a single linked list. What does a single linked list look like? So the question given us a defined class list node. For each list node, it contains a data field like integer 1 here and a reference to the next node in the sequence. So what happened when executing the statement list node cur equals to new list node 1? On the right side of the equals sign, the new operation allocates space for a list node object on the heap at memory address 0024. On the left side of equals sign, cur is a reference to the object. Currently, cur holds the address of the object and resides on the stack in memory. To make it easier to understand, I'm gonna use a metaphor. Suppose I have a house numbered 0627. Clearly, this house is an object. So this house tag with the number 0627 is a reference, also known as a pointer. My next question, what happens when executing the statement list node pre equals to cur? A new reference pre is created that points to the same memory location as the existing reference cur, which is 0024. It's like I got a new house tag copying the same house address number 0627 as a reference of my house. So what does a single linked list look like? Let's take these 3 list node instances as an example. Space is allocated for node 1 on the heap at the memory address 0627. Space is allocated for node 2 on the heap at the memory address 0316. And space is also allocated for this node 3 on the heap at the memory address 0826. Node 1's next pointer is pointing towards node 2, as you can observe. Node 1's next reference is 0316, which is the memory address of node 2. Node 2's next pointer is pointing towards node 3. As you can observe, node 2's next reference is 0826, which is the memory address of node 3. In a single linked list, the last node holds a unique characteristic, unlike the other nodes which have a reference to the next node in the sequence. The last node does not point to any sequent node. Instead, it points to now. This indicates the termination of the list. The given question provides us with the head reference of the first node as input. Therefore, head pointer holds the memory address 0627 of the node 1's object. What does a reversed single linked list look like? As we mentioned, this is what a single linked list looks like. This is what a reversed single linked list looks like as an output. After reversing the given single linked list, the position of each node and its next reference have changed. As required, we should return the head reference of the reversed linked list. Let's take node 1 for example. To reverse a single linked list for node 1, our goal is to transform node 1 from first node to the last node. I need a pointer cur to help me iterate through each node in this given single list. I need a pointer next to help me maintain the current next reference of node 1 before I lose it. I need a pointer pre to update node 1's next reference from previous 0316 to now. Alright, let's go through the code together. I'm gonna iteratively reverse a single linked list. We need to examine the corner case. What happened if the head is now? This would imply that no linked list exists. We can directly return now. As I mentioned, I need a pointer cur to help me iterate through each node in a given linked list. I need a pointer next to help me maintain the current next reference of node 1 before I lose it. I need a pointer pre to help me update node 1's next reference. So let's initialize those pointers in hand. And here, pointers pre and next are both initialized as now. You can consider of this like a blank house tags with no writing on them. To reverse a single linked list, our goal is to firstly transfer node 1 from the first node into the last node. I need a pointer next to help me hold the current next reference of node 1 before I lose it. So by executing this statement, current next reference is be copied to next reference. So currently, next pointer is helping me maintain the current next reference, which is 0316. And pointer pre is to help me update node 1's next reference from 0316 to now. Pointer cur is used to iterate through the nodes of the linked list. Before pointer cur moves to the next node, pointer pre would copy its reference, which is 0627, and pointer cur gets a copy of pointer next, which is 0316, successfully moves to next node. I will put node 1 here to make it more clear. We will continue this while iteration. To reverse a single linked list, our goal for node 2 is to transform from the first second node into the last second node. And the node 2's next reference should pointing to node 1. So I need a pointer next to help me maintain this current next reference. Now pointer next is helping me maintain a current next reference, which is 0826. Pointer pre helps me to update node 2's next reference from 0826 to 0627. The pointer cur is used to iterate through the node of the given linked list. So before pointer cur moves to the next node, pointer cur would give a copy of its reference to pointer pre, which is 0316. And pointer cur get a copy of pointer next's reference, which is 0826. Successfully moved to the next node. Continue this while iteration to reverse a single linked list. Our goal for node 3 is to transform from the last node into the first node. And node 3's next reference should pointing to node 2. So I need a pointer next to help me maintain a current next reference of node 3. Now next is holding the value now. Pointer pre helps me update node 3's next reference from now to 0316. The pointer cur is used to iterate through the nodes of the linked list before pointer cur moves to the next node. Pointer pre would copy its reference, which is 0826. For this statement, pointer cur would get a copy of pointer next reference, which is now currently. So we exit the while loop. Yes, we will return a reference pre who points to node 3, which is the new first node in this reversed linked list. Perfect. As you can see that this is exactly what we want for our output. You might also notice that I didn't use head pointer during the whole process. Well, I know some prefer to use the head pointer as the current pointer to iterate through the whole linked list. I chose to iterate a new reference named cur for this purpose. It's just my personal preference. All right, I hope you like this video. Thanks for watching. I'll see you next time.